Hey guys, Mr. Middleton here. Today we are going to look at order of operations. Okay, at the end of this video, you should be able to use the order of operations to simplify expressions, and you should be able to evaluate expressions using the order of operations. Okay, so the mathematical order of operations is used to simplify expressions correctly. Okay, and expression is a mathematical phrase. Okay, so which means that it does not have an equal sign. Okay, it's not a mathematical sentence because a mathematical sentence has an equal sign, but it's a mathematical phrase like a piece. Okay, so an acronym often used to help us remember the order of operations is PEMDAS, or please excuse my dear Aunt Sally. Okay, and this acronym, all those things stand for something else in its place, a mathematical consideration you should take in order. Okay, and so as we go through, I'm going to change the color because I have two light blues up. It's not going to be helpful for me. All right, so as we look here, P stands for parentheses. Parentheses. We should consider parentheses first as we simplify expressions, and then exponents. You'll notice that we have a box here, multiplication, division. I'll talk about that in a little bit. Multiplication, division. And then we have the same kind of box here with addition and subtraction. Here we go. I'm going to make that an M, make that a D. All right, be uniform. Okay, so you'll notice here that in the box that we have multiplication and division linked. And that's because with multiplication and division, we don't do all multiplication and then all division. We actually work those from left to right. And the same with addition. We don't do all addition and then all subtraction. We work those from left to right. And the reason we do that is because they're the same thing, right? So if you have a calculator by you, or if you just want to do these numbers, if I said, okay, 8 times 1/2, that answer is 4. Okay, multiplying by a fraction, okay? Or if I said 8 divided by 2, that answer is 4. And the reason that that answer is 4 is because multiplication and division can be written really as the same thing. Okay, I can write a problem, the same concept as a problem in multiplication and in division. Okay, if I want to get 1/2 of 8, I could keep it as a multiplication problem, say 8 times 1/2. Or if I wanted 1/2 of 8, I could say 8 divided by 2. Okay, I'm asking for the same thing both different ways. Okay, so whichever I ask first, left to right, is the one that should be done first in order to simplify correctly. Same with addition and subtraction, a little bit easier to see. If I said 3 plus -2, that's the same as me saying 3 minus 2. Okay, so addition and subtraction can be written the same. I can write an addition problem using subtraction, or a subtraction problem using addition, just as I could write a multiplication problem and a division the same way. Okay, so that's why those boxes are there. Know that those two are linked because multiplication and division are really the same thing. And we just talked about it, but I'll fill in the spaces from left to right. All right. So this first example says 8 divided by 2 times 4. If you do the multiplication first, so 2 times 4 is 8. 8 divided by 8 will be 1. You get 1. However, if you do the division first, 8 divided by 2 is 4. 4 times 4, you get 16. Okay, and therefore, order matters. The correct answer would go from left to right. 8 divided by 2, 4. 4 times 4, 16. The correct answer is 16 in this case. All right, so let's look. It says use the order of operations to simplify each expression. And I invite you to try these problems before I do them if you'd like to see how it goes. You can pause the video and try it if you'd like. Okay, so here we go, from left to right. Well, actually, here we should first consider the parentheses. 14 plus 3, 17. 32 plus 36 minus 17. 32 plus 36 is 68. Minus 17 is 51. And so our answer, our first problem, simplified is 51. And 51 is a lot simpler than our original statement that we were given. All right, numero dos, from left to right. 15 divided by 2/5. Okay, a little bit of review here. Remember, to divide a fraction means to multiply by its reciprocal. So I'm going to do that over here. 15 times 5/2. Okay. 15, I'm going to write that as a fraction, order 1. So that's like what, 75/2? Okay. 75/2 here. We have an addition sign. We don't want to do that right away because we have a multiplication sign. We have to do multiplication before we do addition. So 1/4 times 8. Do that over here. 1/4 times 8. I'm going to write 8 as a fraction because numerator times numerator. 8, denominator times denominator, 4. 8/4 is 2. Okay, and now we have to add these fractions. Remember, when adding fractions, we need to have a common denominator to add or subtract. So I'm going to make this a common denominator. The common denominator between 1 and 2 is 2. So I have to multiply by what gives me the 2. And so that would make it 4 halves. So 75 plus 4, 79 halves. Okay, which is almost 40, it's like 39.5. Number 3, as we go through that, should be pretty straightforward from left to right. 12 minus 4 is 8. Should do that. 12 minus 4 is 8, plus 3 is 11. What a doozy. Let's try number 3. We have 3/8 plus 1/2. Okay, so what we're going to want here, and I'm going to zoom in because I want a little bit more space to work. Okay, so what we'll have here then is we need to make sure that we get these fractions to be common denominators. So I can make these both 8s, right? Just multiply this by 4. So I have 3. Oops, need to make that skinnier. Okay. So we'll have 3/8 plus 4/8, which gives me 7/8, right? And that's in parentheses still. Minus, and as I go through the same considerations here, these both get to 12, so multiply that by 4. 8/12 plus, multiply that by 3. Make sure I write work here. Plus 3/12, and that's 8 plus 3, 11/12. And that's in parentheses. And you'll notice that these are in parentheses, and then they had brackets around them, which is like a double parentheses. So now as we do these two, we need to have common denominators again. And so far, we kind of had them, we're able to like match them up to a number. And here we had to multiply this by 4 and multiply this by 3. But remember that we want to have the least common multiple. And so when I look at 8 and 12, the lowest number that they both can go to is 24. Okay, and so in order to get this to 24, I'm going to multiply this by 3, right? So I can multiply this by 3. I can multiply this by 2, and so I multiply this by 2. All right, so this 3 is still on the outside here. Okay, so as I go through and do that, that will give me 21/24 minus 22/24 times 3. And that will give me negative 1 over 24 times 3, which gives me negative 3 over 24, which I know feels like a long time and you want to be done, but we have to simplify, and that gives me negative 1/8. Whew, told you it was a doozy, but we got it done. And we didn't have to worry about whether we were doing it in the right order or not. We just had to do math. Okay, which reviewing fractions is something that we'll want to make sure that we do so that that is not a stumbling block for us throughout the semester and year. Okay, so evaluating expressions. When you evaluate expression, you are replacing a variable with a value, okay, or a number, okay? It is a good habit to use parentheses whenever you do this for 2 reasons, because it does tell us that we're going to be multiplying typically if it's right next to a number, and also it will help us to keep our signs and figures correct if we are inserting a negative number or using exponents in its place. So what evaluate means here in math terms is just plugging in and simplify. Okay, sometimes when you say evaluate, it's like tell how good it is, like rank it, rate it, but that's not what it means in the math terms. So here, when it says evaluate 3x plus 2y when x equals 5 and y equals negative 2, it means plug these values in. 3, x is 5. 2, y is negative 2. And then simplify. So evaluate means substitute and simplify. So 3 times 5 is what we do first here, because it's multiplication. 2 times negative 2 we do next because it's multiplication. And this sign we haven't touched. Okay. Anytime there's 2 operation signs next to each other, I like to see, okay, what does that mean I'm doing? Okay. So when I have a plus minus adding a negative, that means subtraction. Okay. So I have 15 minus 4, or plus negative 4. And that gives me 11. Number 2, x is 5 minus 2, negative 2. Okay, so 5 minus negative 4. Okay, minus a negative, remember, is going to be positive. So minus a negative is plus 5 plus 4, 9. We've got 2x minus 7 times 4y plus 3. Again, we're plugging in our values. So we got 2x, which is 5, minus 7 times 4y, which is negative 2, plus 3. Okay. So I need to do this first. 2 times 5 is 10. 10 minus 7 is 3 over here. 4 times negative 2 is negative 8, plus 3 is negative 5 over here. 3 times negative 5, negative 15. And then here we have negative 2 squared divided by 13 minus 5. And here's where plugging it into parentheses really does help, because in your calculator, you want to make sure you plug it into parentheses. If you don't do that, if you say negative 2 squared without parentheses in your calculator, like if you do this to your calculator will follow order of operations. And your calculator will say, well, I have to do exponents first. And it'll do 2 squared, which is 4. And then this negative 1 is kind of treated like this negative is kind of treated like a negative 1. So your calculator, if you just plug in negative 2 squared, will tell you the answer is negative 4. That's not right, okay, at least in the sense of how we are thinking of it. We are thinking negative 2, that number, squared. If you plug it into your calculator this way, it'll say, okay, that means negative 2 times negative 2, which is positive 4. Okay, divided by 13 minus 5, which is 8. 4 divided by 8 will give us 1/2. Okay, we could write it like 4 over 8, 1/2, 0.5. Okay, you should be able to do all of these. Okay, So please don't be stuck on only using decimals because that's what the calculator says. If you can understand division is a fraction, then you can reduce the fraction. You can use all these, and it makes understanding your answer a lot easier in multiple cases. All right, so let's look at our example here. And it says, John claims that x plus y squared equals x squared plus y squared. Is John correct? So when we look at this and we have the values for x and y, they told us that x was 5, and they told us that y was -2. Okay. So as we do this, we're like, okay, 5 plus -2, that's 3, right? And 3 squared is 9. Well, x squared plus y squared, that would be 5 squared plus -2 squared. Right, so that would be 25 plus 4, 29. Are these the same thing? I guess I could have used different notation there. I don't know why I'm asking you if 9 is the same as 29. It's not, right? They're not equal. So is John right? No. John is not correct. Reason is that we had to make sure that we use the correct order of operations, and correct order of operations would be to simplify here before we squared it instead of squaring it, okay? Because he tried to do, I'll say, exponents first instead of doing the parentheses first, he got an incorrect answer.